for this video, we'll be looking into another question about osmotic pressure. Okay, so if you look at this one, is a question, right, asking, okay, which of the option has osmotic pressure of 7.89 atm at 37 degrees C? Okay, so then apparently now we need to find out from which choice, which solution will exert this or give us this 7.89 atm as the osmotic pressure. Okay, so now again we know once this is osmotic pressure is mentioned, we know I have to go into the osmotic pressure equation and then see what we can know from there and then take our actions. Okay, so osmotic pressure equals to I Van Hoff's factor times molarity times R, which is the gas constant, times T temperature. Okay, so then have this relationship. Again, from this particular question, we know we're searching for a certain solution. We're having this 7.89 atm as a pressure, okay, equals to I equals to Van Hoff's factor. And then that's also something we need to look through our options and then see how that affects our choice, right? Okay, so then times molarity. Molarity is also given, but then it's different. So then we need to look into that as well. So then I'm going to keep it like that. Okay. But R value, we know which one to use. Then you go, I'm a little iffy about which one to use because I have different R values, as we keep on saying, right? So whichever one you will be using depends on which R value is more convenient in that situation. Since this question involving ATM, so then of course the R value we use probably should also include that unit, so then it's easier for you to cancel out, right? Okay, so then therefore we know, okay, we should use R value as the 0.08206, which unit has ATM times liter over mole times K, right? Okay, so now in this case, we can cancel the unit. Again, that's convenient, right? Okay, and of course, once we have this R value written out, then we also realize what the unit should be for the K, the temperature should be Kelvin, right? Okay, so then multiply, the temperature should be 37 degrees C plus 273. We're converting, right? Converting the degrees C to Kelvin. Therefore, that can be canceled out. Okay, so now I have this set up. Okay, so then let's see if I can bring this over. Oops, okay, nope. Okay, so let me do that. Okay, so now we just, right, as I said, because of the choices, we need to see for each choice the Van Hoff factor and molarity. Okay, so then that's the two variables. Okay, but then we can solve the rest, right? Okay, so now I'm going to put the two variables on one side. Van Hoff factor times the molarity should equals to 1. Okay, so of course you can quickly solve for that. Okay, so then we got 0.310 molarity. Okay, so then you go, oh, Van Hoff factor, I know molarity equals, right, have the same unit, that's fine, but Van Hoff factor is just a right whole number, at least expected Van Hoff factor should be just a whole number, right? Okay, so that anyway, so it has no unit, so just a number, so then that makes sense. So now our job turns into what? We need to find throughout the options which option give us Van Hoff factor times similarity equals to 0.310. Okay, so if we find that choice, then that's our answer. Okay, so let's see how we can look into that. So our choices, let's start from choice A. Okay, choice A. Choice A, then we have this as 0.155 molarity. Okay, and then we'll have this glucose solution. Okay, so then the question will be, okay, what's the Van Hoff factor for glucose? Okay, so then you go, how do I know, right? That's also why we need to recall the electrolyte concept. Okay, so glucose is a what? Look at what's involved in this compound, all nonmetals, right? So how they're bonded by sharing electrons. So then therefore again is a molecular compound. When you put it into aqueous solution, what happens? It's not going to dissociate, stay as a whole unit. So then, therefore, the Van Hoff factor for that is 1. Okay. So then, now for choice A, we're going to write it down. So it's going to use Van Hoff factor times similarity. We figure out that's going to be 1 multiply 0.150. So then this will be 0.150. Okay. So then it's not 0.310 as we're looking for, so then that's not a choice. So we're going to keep on working on the next one, same logic. Okay, so then what's the Van Hoff factor for sodium acetate? Okay, so you go, how do I know? It looks complicated. Okay, so again, we know sodium has, well, it's a metal, has positive charge, and this acetate, you go, I don't know what's acid, right, what's this? Okay, so then again, as a whole, an ion, as a together. Okay, so then you'll have sodium ion, okay, and the acetate ion. Okay, so then what's the Van Hoff factor? It's going to be 2, right? Okay, so now that's 2. So I times M should equals to 2 times 0.10. That gives us 0.620. Okay, again, that's not the choice either. Okay, so now let's keep on going. What about C? C, what do I have? I have 150. But however, let's look at this one. Let's see what's the Van Hoff factor for sodium phosphate. Okay, so I think we get a hand of this, right? So when you put this is a salt, right? Okay, so ionic compound, when you put it into aqueous solution, what happens? It's soluble, so it's going to be 100% dissociated into ounce. So then you have, what do I have? Let's put those down. So you have sodium ion and phosphate ion. But how many of each? We're going to look into the subscript. Okay, so we'll have 3 of the sodium ion plus 1 of the phosphate ion. So then we have 4 ions. So then Van Hoff factor will equals to 4. So then I times m equals to 4 times 0.150. That's going to be 0.620 again. Okay, so again, that's not our choice. Okay, so let's look at D. So D will have Van Hoff factor, so we'll have KCl. That's also another soluble salt. So dissociating to sodium ion and chloride ion, 1 of each, because the subscripts are just 1 and 1, right? Okay, so then Van Hoff factor will be 2. So I times m equals to 2 times, what's this concentration? 0.155, give us 0.310. That's exactly what we're looking for. So then that's our choice. Now let's keep on looking at the last one anyway, because again, right? Yes, finding the answer, but since we are looking into learning the concept behind this question, so then let's go look into it. Okay, so what's wrong with E? Okay, so E will have calcium chloride. As you know, you will have calcium ion and 2 of the chloride ion. So then I should equals to 3, 1 plus 2. Right? Okay, so then Van Hoff factor times m equals to 3 times that 0.310, giving us 0.930. Okay, so then that's not something we're looking for. Okay, so then for this question, requires some calculation and then requires our understanding. Really, if you look into it, yes, it's about osmotic pressure, also really about our understanding about Van Hoff factor and how, right, how that Van Hoff factor plays in the role of, right, colligative properties in terms of the number of particles actually involving in the solution. Okay, so then that's the end of this question, and hopefully this is helpful.